So for today's video, we're going to talk about the volume of sphere or the balloon problem, for which we find the rate of change through the volume of the sphere using derivatives. Now for all we know that the volume of sphere is being calculated as 4 over 3 multiplied to pi times r cubed. Now, we know the concept of derivatives. So, let's get on with the problem. So for this problem, air is pumped into a spherical balloon at a rate of 450 cubic centimeters per minute. How fast is the radius of the balloon changing when r is equals to 10 centimeters? Now for all we know that r is equals to 10 centimeters. But what about 450 cubic centimeters per minute? Since it's cubic, we know that it is associated with volume, so let's represent it as dV over dt. Since the unit is cubic centimeters per minute, so it's volume over time. So let's rewrite it as 450 cubic centimeters per minute. Now we're finding for the rate of change, so let's represent it as dr over dt. Now, how do we find this? So since we're talking about a sphere, let's use the formula for the volume of sphere, in which V is equals to 4 over 3 pi r cubed. Now let's find the derivative with respect to time. Now, the derivative of V is 1 times dV over dt. Now, 4 over 3 multiplied to pi is a constant, so let's rewrite it as 4 over 3 pi. Now, the derivative of r cubed is 3r2 times dr dt. Now, let's cancel 3 on both sides, and let's represent dV over dt as 450 cubic centimeters per minute. So I'm going to write 450 equals to 4 pi r squared dr dt. Now, r is represented as 10, so let's write it as 10 squared. Now, running out of space. Oops, sorry. Now, if we multiply 10 squared to 4, we get 400. So let's divide both sides by 405. Which I'm going to write it right now. 450 over 405. Cancel out 400 since it's going to divide by itself. So we get dr over dt is equals to 450 over 400 pi. Now we need to simplify this. So 450 and 400, what do they have in common? Well, from what I know, that 450 and 400 is common to 50. So let's divide both numbers by 50, and we will get 9 over 8 pi. So the answer, or rather the simplified answer, is equal to 9 over 8 pi. And there you have it. So now that you know how to calculate the rate of change through the volume of sphere using derivatives, I think it's time that we say goodbye. Bye-bye!